In this example, I'm going to show you how to find the derivative of y. Note, if y equal to e to the x, therefore y prime is e to the x. However, if your exponent here is complicated other than x, then we have to use the chain rule. So I'm going to show that next example. I'm looking for y prime. 3 is a constant, so I leave like that. The derivative of e to the x is e to the x. B. I have y equal to x squared times e to the x. So because I have something of x times something of x, therefore I have a product here, so I need a product rule to do this. Remember, the product rule say, if f of x equal to u of x times v of x, therefore f prime equal to u prime times v plus u times v prime. Okay, so I let u equal to x squared, therefore u prime is 2x. Let v equal to e to the x, therefore v prime is e to the x. So therefore our y prime will be, using this, 2x times v is e to the x plus u is x squared times v prime is e to the x. Okay, I see that I have two terms that have e to the x in the common and also x in the common. So I pull out e to the x and x. So I pull x and e to the x out from here. I left with 2 plus. Then I pull out e to the x and x. I left with x. So this is our answer. C. Y is e to the x over x to the cube. I have something of x divided by something of x, therefore I need to use the quotient rule. Okay, so let's remind ourselves the quotient rule. If f of x equal to n of x over d of x, the quotient rule is the f prime will be n prime times d minus n times d prime over d squared. So I'm gonna let n equal to e to the x. Therefore, n prime is e to the x. And let d equal to x to the cube. So this is my problem here. Let n equal to e to the x and d is x to the cube. Therefore, d prime will be 3x squared. So now to find y prime, I'm using the quotient rule here. I will have e to the x, which is n prime, times d, where's d? D is here, is x to the cube, minus n, which is e to the x, times d prime. D prime is 3x squared over x to the cube squared. Now we will simplify. In the top, I have e to the x times x to the cube minus e to the x times 3x squared. I see that this is two terms, one term minus another term. They both have e to the x in the common, and they both have x here and x there. So I pull out x squared. I have x minus 3. Because when you multiply this here, you will have that term. This guy times this, you have this term. Over x to the 6. I see that I can cancel x squared and x to the 6. I cancel it out. I have x to the 4 here. So I have e to the x times x minus 3 over x to the 4. That is our answer. Our answer here is simplified. Beautiful.